Okay, on the front side, we're actually going to get into some examples so that we can understand what was the point of having those restrictions and how does that impact us in terms of examples. So we're going to fill out today these top 4 windows of our foldable. And this top window right here is actually just review questions. These are just review questions from chapter 6. All we're doing is we'll be given a trig function and an angle. So if we go ahead and we open these up, we can see very quickly that this one's going to go pretty fast. If I'm asked to find secant of 5 pi over 4, what I can remind myself is where does that land? I can see that it's going to land me in this third quadrant here. Secant is of course the reciprocal of cosine, so I'm going to do the reciprocal of my radical 2 over 2, or in other words just a square root of 2. And of course in that quadrant, secant is going to be negative. Moving along to our unit circle, thinking about our tangent of pi over 2. If you want, you can give yourself a little visual reminder that it's right up there at top. Tangent works just like slope. Slope of the y-axis is undefined. So we would be done with that one. So this top left window is purely just review. If we move to the window that's right next to it, these are where we're going to think about our restrictions, and what we're going to do is we're going to work those unit circle problems backwards. Now you'll see that I've already written a little note here and I've highlighted that this is going to be an inverse. Our notation, remember, for an inverse will have what looks like an exponent of -1. That's how we indicate our inverses. Our answer, since we're working backwards, our answer will actually be an angle, because when we did our previous window, our answer was a ratio. So as we're working an inverse, what follows will always be a ratio, and our answer will be an angle in an appropriate quadrant based on our restrictions. Always remember that angles in the 4th quadrant will be negative coterminal angles. So I have an inverse cosine. Now as soon as I see inverse cosine, I like to give myself that good mental visual of what my restrictions are. And I know that cosine, we eliminated the 3rd and 4th quadrant. So what that tells me is that I'm looking for one of these 2 quadrants where my cosine ratio is negative. Well, I know that has to be in the 2nd quadrant. Then I'm asking myself, where does cosine equal a square root of 3 over 2? Well, on my unit circle, cosine equals square root of 3 over 2 at pi over 6. Moving that to the 2nd quadrant would be 5 pi over 6. That would be my final answer. Similar process for tangent. I like to give myself a visual. What quadrants have I eliminated or restricted? For tangent, I have eliminated the 2nd and the 3rd. I'm looking for where is my tangent ratio going to be negative in my acceptable quadrants. So that's going to be down here. When does tangent equal 1? Well, that would be at pi over 4 if it was in the 1st quadrant, but instead I want to move to the last quadrant thinking negative coterminal angles, so I'm going to write my answer as negative pi over 4. And that's all I would do for that one. Okay, moving on. Don't worry, we are going to do a lot more examples like this with these in class. Next window. These are going to be our first taste at a composition of a trig function and its inverse. Now what's very important on this window is that the trig functions that you're going to be given will be the same. So cosine, cosine, sine, and sine. Also on this problem, the inverse will be on the inside of this. So remembering, when we're working with an inverse, what immediately follows must be a ratio that we had been given when we evaluated some angle. The next thing that we want to think about is we want to think back to when we did function composition and we were verifying inverses. What we learned is that if 2 functions were inverses of each other, so if f and g are inverses of each other, they would cancel each other out and we would get x. And what we learned is when these were inverses, it didn't matter what order we did the function composition, we always got x. The same idea is going to apply here. If I have cosine and inverse cosine, what I know is that those have to cancel each other out. So I've written a note here. If this is a ratio, what I need to ask myself is if 2 is in the appropriate range for a cosine function. In other words, is 2 inside the interval, so we can write it out. We know that the parent function for cosine, the range, is actually -1 to 1. 2 is definitely not in that range, so we would actually say that this problem is undefined because it is not possible. So that's all I would need to do for that. For sine, again, I have sine and inverse sine, so those will cancel. And then I need to ask myself, I need to verify, since this is a ratio, I need to verify that what is my range for sine? My range for sine is also -1 to 1. Is -1 in that interval? Yes, because the ends of this range are inclusive. So my answer would be yes, it would be. And my answer would then be -1. So on this problem, I can keep the ratio because it's in the acceptable interval. On this one, I had to say undefined. Last window, again, a function composition with the same trig functions, but this time the inverse is going to be on the outside. These ones can be a little bit tricky. So what I want to do on these problems is, again, I understand that these are going to cancel. Since the inverse is on the outside, I know that this is an angle. Don't be tricked just because it has a pi that makes it an angle. Same thing here. These will cancel. This has to be an angle because the inverse is on the inside, or is on the outside, not the inside. What I need to do here is I need to verify that the angle they've given me is in an accepted quadrant, and if it's not, I have to move it. So I'm going to think to myself, give myself a little picture. What quadrants have been restricted or eliminated for cosecant? If you need, you can flip to the back, but we've eliminated those two quadrants for cosecant. Now, if I go ahead and I sketch in where 5 pi over 4 lands, I would see that 5 pi over 4 actually lands in the third quadrant. It's in a restricted quadrant. So I'm going to think all students take calculus again, and what I can see is that in this quadrant, my cosecant would be a negative angle, a negative value. So if I evaluated cosecant of 5 pi over 4, I would get something negative. So what I'm going to do is I'm going to come over here and I'm going to figure out which one of these two quadrants would also give me a negative ratio for cosecant at 5 pi over, just like it did for 5 pi over 4, and it would go right here. Cosecant being the reciprocal of sine, I could move it here. Remember, anytime you want to give an angle as your answer, in the fourth quadrant, it has to be a negative coterminal angle. So my final answer here will be negative pi over 4. Tangent, I can repeat that process. Remove the quadrants that you know you're not allowed to use. Figure out what angle they gave you. Where does that land? It lands right here. That's in a restricted area, so I'm going to move it to another location that's in the accepted interval that would give me the same answer that I would get for tangent of pi. So tangent of pi is 0. I'm going to move it back over here. So if I move it to its equivalent spot, my answer would be 0 radians. And those are the only examples that I'm going to do today, and then in class we are going to do a lot of practice.